Okay, so when we're doing our permutations, there's situations where multiple things could happen in terms of we could have this or that, such as we are going to have to arrange 7 people or 9 people, depending on how many show up. And in that case, we have multiple situations, and thus in those cases, all we do is just add the events. So if we have an or situation where we're going to have, we're going to award medals in a race, and we're going to award first, second, and third, or if someone does really well, we'll award first, second, third, and fourth. So we have an or there. So we add up the permutations for 1 to 3, as well as the permutations from awarding 1 to 4. So here's an example. We'll work out. Jack invites 7 friends to the movies. Jill may or may not be able to attend. So how many ways can they arrange themselves in the same row if Jill attends or doesn't? So we have 2 situations. If Jill attends, then we have 7 friends plus Jack, so 8 people. So that arrangement would be 8 factorial. We can arrange people 8 ways. If Jill doesn't attend, then it'll be Jack and 6 friends, so we'll have 6 factorial. So 8 factorial ways to arrange the group of with Jill arriving, and then 7 factorial ways of arranging if Jill doesn't arrive. So we just add those 2 up, and that will give us our total number of permutations if Jill arrives or doesn't arrive. So we have 8 factorial plus 7 factorial. That's going to give us 45,360 different permutations if Jill attends or doesn't attend. In this next situation, we have some things where we may have to exclude. So a teacher's picking volunteers for a charity event. 6 grade 11 girls, 5 grade 11 boys, 7 grade 12 girls, and 8 grade 12 boys volunteer. There are 3 different positions available. So we want to know how many ways the teacher could pick all girls or all grade 12s. And so we're going to set this up with a Venn diagram just to help us out a little bit. So we're looking for all girls or all grade 12s. But there are girls that are in grade 12, so we're going to have some overlap. So we're going to have 2 circles here, and there's going to be overlap. So this is maybe the girls, this is maybe the 12s. Okay, I'll just circle those. So the total number of girls is 6 and 7, so there's 13 girls. But 7 of them are in grade 12. So there's 7 girls in grade 12. So that's the overlap total. And that leaves 8 grade 12s, just the 8 grade 12 boys. And then the number of girls is just the grade 11 girls, which is 6. So we have 6 girls, 8 grade 12s, and then 7 people in the overlap. So what we're going to have to do here is look at the principle of inclusion or exclusion when we're calculating this because of that overlap. So when we do that, we're going to have the number of having girls, all girls, or all 12s is equal to the number of ways we can choose girls plus the number of ways we could choose the 12s minus the number of ways we could choose girls that are also in grade 12. So G, girls and 12s. So just like our probability of inclusion and exclusion, same idea here. So the number of ways that we could choose all girls is 6 and 7, so 13 girls. We're going to select 3. The number of ways we could choose grade 12s is the 7 and 8, so 15. Sorry, 15, and we're going to choose 3 of them, minus the 7 in the overlap. The 7 grade 12 girls represent the overlap, so how many ways would the overlap be represented? Is 7, and we're picking 3. So 13 pick 3, plus 15 picking 3, and 7 minus 7 picking 3. That's going to give us our total. So we'll work that out. So if we have 13 and that's 17, 16, and then the next one is 15 and 15, and we're choosing 3, so that's 27, 30 minus sorry, just my calculator's slower as I got to go through a few steps to get there. 7 choosing or picking the 3, we have 210 that are represented in that overlap. So we have 17, 16 plus 27, 30 plus, or sorry, minus 210. There's 4,236 ways of choosing all girls or all grade 12s. So again, what we did, with the situation where there's the overlap, we look at the number of ways of choosing one option and the other option, we add them up, and then we look at the possibility of the overlap and how many arrangements are there and subtract it to get rid of that one set of doubles. And now, another situation is that sometimes we're dealing with things and we have so many outcomes, it's easier to subtract the outcomes we don't want than to calculate all the different ORs. So if there was a full series of 10 things, 10 different outcomes that are possible. You know, you could select 1, or you could select 2, or you could select 3, or 4, or 5, or 6, or 7, or 8, or 9, or 10. And we just wanted to know the number of arrangements of selecting 1, 2, 3, 4, 5, 6, 7, or 8. That's 8 different calculations. But we could just do 2 calculations of 9 and 10, selecting 9 or selecting 10 of the items, of the items, and then subtracting that from the total outcomes. So let's take a look at that in a visual or an actual question will help us see that a little better. So how many ways can the letters in the word super be arranged if the vowels are to be kept separate? So the total number of ways that we could arrange the letters with no restriction, we have 1, 2, 3, 4, 5 letters, and we're going to arrange that. So 5, and we're going to use all 5. So 5, P5, and that's just 5 factorial, which we've often seen is 120. Now, if we have to keep the vowels separate, that means they're not going to be together. So what if we looked at the vowels, the U and the E, as if they were together, and then subtracted the ways they're together from the total number of ways. That would leave all the cases where they're not together. So the total number of ways is 120. So the vowels together would then be, since U and E are one item, there's only 4 options now. So we're doing 4 options, 4 spaces, and we're arranging 4. But because there's the 2 letters together, we need to multiply that by 2 arrangements of 2, or 2 factorial. So this is 4 factorial times 2 factorial. And 4 factorial is 4 times 3 times 2, and then we're times 1 times another 2 times 1. That's going to be 48 arrangements where the vowels are together. Vowels together. Thus, the ways the vowels would not be together is the total minus 40, the ways they are together. So vowels not together is 120 minus 48. And then 120 minus 48 is going to give us 72. So again, instead of trying to figure out every case where, okay, what if the U's first, or what if a vowel's first, and then what if a vowel, like you have to space them out. There's the cases in that are add up. Where here, we were able to easily treat them as one thing. So if we treat them together, how many ways can we keep them together? Subtract that from the total number of ways, and we're able to find out the ways they're not together. So again, with the rule of sum, when we're working with situations where this or that happens, then we're adding things together. And then in terms of trying to find those out, if there's situations where we have unwanted outcomes, sometimes when there's these restrictions, it's sometimes easier to think about things being, the easier way of selecting items might be to take the things we don't want away from the total number to find what we actually want.